Hello everyone, my name is Ziyang Tang, and today I'm going to present the review of the paper Majority is Not Enough, Bitcoin Mining is Vulnerable. First, I will introduce what is Bitcoin and a few terms. Then I will discuss the current defaults and the selfish mining strategy, followed by the analysis of the reward from selfish mining strategy and how to defend such attack. Finally, I will summarize the highlights of this paper as a conclusion. As we all know, Bitcoin network has grown into a large market and its whole value is about 12 billion US dollars. Numerous computing power were used to solve the crypto puzzles, and the whole computing power can be a very large FLOPS. I also checked the value of the Bitcoin today. By now, the one Bitcoin is worth over 10,000 US dollars, so it's very valuable. Since Bitcoin is very valuable, the next question is that how can we get Bitcoin for free? So from the Bitcoin's mechanism, we know that Bitcoin is a decentralized currency based on the blockchains, and the blockchain is a very long chain that's connected by the blocks. In each valid block, people need to solve a crypto puzzle in the form of hash, and the first one who solves the puzzle will be rewarded a new Bitcoin. So the process is called the Bitcoin mining. Meanwhile, other computing power for the same puzzles will be abandoned or ignored, so their efforts will be wasted. Because the speed of solving the puzzle is related with the computing power and the rewards. So the miners decide to work together as a pool and share the reward by the computing power they contribute to the pool. Therefore, miners in the same pool can also be known as the members. So let's assume that each member in a pool is rational, and their goal is to maximize their rewards in a mining process. So does it exist a strategy that, if applied, the members can earn more reward than their ratio of the mining power? And the answer is yes. So here comes the selfish mining strategy. This is a strategy allows a pool of sufficient size to obtain a reward larger than its ratio of mining power. So for example, if a pool only have about 1/10 of the whole computing power, but they want to earn more than 1/10 of the Bitcoins after finding a new block. So they will develop a method to achieve that. And because the method is very selfish and do harm to the whole community, so we divided such group as concluding group or the selfish group, and in contrast, other majority will be named as the honest group. So how does this selfish mining work? The idea is very simple. We know that the Bitcoin only valid the longest chain. So if there's two branches, and the Bitcoin network will only apply the longest one, and the other one will be useless and abandoned. But because the Bitcoin network propagates the block information through the whole network, some node may hear from the branch A and another will hear from the branch B. So in this case, some nodes work will be abandoned because of the information they heard is in the short branch. So their efforts will be wasted and will be invalid. So if the selfish group want to abandon the work from the honest group, they will keep it. If they find a new block, they will keep it private, and then they will continue to looking a new one to extend their private chain. And once honest pool find a new block, then the selfish pool will immediately release their private chain and then abandon the link from the honest chain. So if in this case the work from the honest group will be wasted, and when the members from the honest group notice that such a selfish mind strategy can receive more reward because they are rational and they want to maximize their earnings, so they will also switch their strategy and join the selfish pool. In this case, the selfish pool will grow larger and larger, and finally the majority of the whole network also apply this selfish mining strategy, and therefore the computing power will dominate the whole network, and they can control the network, and therefore the whole decentralized currency will collapse because they are controlled by a single selfish group. So after that, we need to analyze like the expectation of the reward if a miner apply the selfish mining strategy. Because if the selfish mining strategy cannot earn more, then the miner there's no need for the miner to apply this strategy. So assume that selfish pool has the mining power of alpha, then the others will have the 1 minus alpha. And if there's exists two branches, the gamma will be the ratio that other nodes that mine on the chain from the selfish pool. And state 0 means that the main chain has the states of no branches, and the state 0 pi is the state that there are two public branches of the length of 1, so the competition will begin. Then how does this selfish mine work? So let's say in the state 1 there's no branches, and in state 2 honest pool find the new block, and immediately the selfish group will release all the blocks they find. And let's say if they has already find 3 blocks, in this case the branches is not tied, so the main chain will adopt the longest one, which is the private chain from the selfish miners. In this case, the honest group, the chain from the honest group will be abandoned, and their work will be wasted. So because they wasted a lot of time finding a puzzle, then in the meanwhile, the selfish group can use this time to extend their private chains and still take the lead. So in this case, they can make more money while the honest group waste their time finding a block and earn nothing. But because the selfish group usually is the only shares a small ratio of the computing power, so their lead can be decreased because the honest group has more computing power. So there exists the probability that the two branches are tied, which means when a new honest group find a new block, the private group only have one block, so they are tied, and there's two branches. So there is a competition between the honest group and the selfish group. So there will be two conditions. One is that the private chain, the selfish group, find the next block and they win the competition, and otherwise the honest group will find the next block and then they win the competition. So if this is the case, because the honest group share more computing power, so usually they can find the next block easily. So in this case, the selfish group will lose the money. So this paper show that the size of the pool size will related to the revenue of the selfish group. So which means if the selfish group grows larger and larger, their reward will be super linearly, and they can earn lots of money. Then they apply this strategy with the honest one. So from the left graph, we can see that when the pool size grows to half, like 0.5, the revenue will be 1, which means that when the pool size grows like half of the computing resource of the whole network, the self group can earn everything in this network, and the honest group will earn nothing. So in this case, this selfish mining can earn more rewards, and if they can earn more rewards, they will attract more miners to switch their strategy into this, and then finally they can dominate the whole Bitcoin network. And the right graph is the gamma, which means because there's no protocol currently to limit it, let's say there's no protocol currently in this Bitcoin network to limit it, the probability of other nodes to mine on the private chain branches. So if there's the probability of more nodes mine on this private chain branches, which means that the threshold of the probability, the ratio of the whole computing power will decrease. And let's say if there's half chance, like 50%, that the other nodes will mine on these branches, the computing power will decrease to like 1/4, which means that only 25% of the computing power can dominate the whole Bitcoin network. So in this case, as long as the gamma increase, the computing power threshold will decrease and will make it more easy for the selfish miner to earn more than their own ratio of the computing power. So so if this is a problem, then the selfish pool will want to increase the gamma. And how can they do that? A common strategy is that they will add a lot of virtual miners to propagate their private blocks. These virtual miners actually have no computing powers to mine the new blocks, but they can propagate their private branches to the other nodes. And in this case, there's more nodes will first hear of the private branches first, and they will start to mine on this branch. In this case, they will increase the gamma, and because the gamma is increased, then the threshold of the computing power will decrease. So they will make this selfish pool earn more rewards, even with smaller computing power. And in this paper, the solution is that if there's two branches are tied or with the same length, then the nodes should propagate both of them and then randomly choose one. In this case, the gamma will be fixed into 0.5 and yield the threshold to 1/4 of the whole computing power. And because from the beginning of this presentation, we know that the computing power is very large. It's kind of like numerous. So even 1/4 of the computing power is very large. And in this case, it will limit the reward from the selfish pool to earn more money. And if we can limit the selfish pool to earn more money, then we can also help to prevent an honest group to change their strategy to the selfish group. So in this case, we can in some degree that defend this selfish mining attack. So in conclusion, selfish mining can be very problematic because once the self-miner dominates the Bitcoins, then the decentralized currency will collapse. And if the currency collapses, there's no one willing to mine more Bitcoins from this network. And therefore, the Bitcoin will have no values at all, and no one want to buy it, and then the whole market will break down. So in this paper, the author offers the strategy to analyze the rewards of the selfish mining and provide a solution to ensure that the pools smaller than 1/4 of the total mining power cannot earn money through this selfish mining. And the author also mentioned that at least 2/3 of the network should be honest, and therefore, as the title said, the simple majority should not be enough to ensure the selfish mining attack. So that's all for my presentation. Thank you.